Hey guys, I wanted to record myself working out some of these half-life problems in case you need to refer back to them when you're doing the rest of these. So I will probably do the same ones in class tomorrow, today by the time you watch this, but that's okay because that means you'll still have plenty of practice problems to try on your own. I won't use them all up teaching you. So there are several ways to go about doing half-life, and there is a formula for you guys that love to plug numbers into formulas, but the reason I'm choosing not to utilize that myself is because there are exponents involved that you would maybe need to solve for the exponent, which involves like doing the natural log on your calculator, and I just don't know where you guys are at in your math classes, what math you're even in, and honestly I'm not a math teacher and I want to always be sure I can explain to you the reason why we're doing something. So I have uploaded some resources onto It's Learning for those of you that want to do this with the formula. It is completely your choice. Be sure you still always show me your work, but if you're getting the right answer and you're using the formula, that's fine. But these practice problems that I'll be doing will be my way, my long way. I'm going to call it my long way. I called it something else on It's Learning, but I can't remember now. Okay, so number one, there's a few options, a few different ways that they might ask you half-life. And I'm going to go through 3 different examples, 3 different things you might be asked to solve for. So number one says, what is the half-life of a 100 gram sample of nitrogen-16 that decays to 12.5 grams of nitrogen-16 in 21.6 seconds? So that is a lot to keep straight, and you really don't know probably off the top of your head what it's asking. So in the beginning you might want to split this up into kind of like a timeline. I think that's what I was searching for a second ago. I think I called it a timeline on my It's Learning. But you want to split it up into 3 different sections. So what is the half-life? What is the time lapse? And the amount. Okay, so this problem gives us a beginning amount, an initial amount of a 100 gram sample. It decays to 12.5 grams in 21.6 seconds. Okay, and it wants to know the half-life. So it gave me my initial and final amount. So I'm going to go through and figure out how many half-lives that went through to decay from 100 to 12.5. So 100 grams. Remember, half-life is just the time it takes to decay by half. So you're just cutting these numbers in half every arrow. 50 grams, 25 grams, 12.5 grams. This is the amount that it wants us to stop at. That gave us 1, 2, 3 half-lives. Okay, the total time, the time lapse, is 21.6 seconds. Okay, and we had 3 half-lives that we went through. Okay, so if we want to know what each half-life was, and this entire timeline took 21.6 seconds, we're just going to say 21.6 divided by 3 equals 7.2 seconds. Okay, so if you like explanations in words, I would just jot down, what did I want you to write? Given total time, then divide by the half-lives. Okay, so the answer to that problem is 7.2 seconds. Number 5 is a little bit different. It still gives us an initial and a final mass, but this time it tells us the half-life and it doesn't give us the total time lapse. So we're trying to figure out how long it takes for 125 grams to decay down to 7.5 grams. So again, I'm going to split all this up into all my possible categories. And guys, as you get better at these, this is not the work you have to show me on your test. Oh goodness, here we go again. Is it going to focus? This is not the test, the work you have to show me on your test. This is just to get you used to this. On the test, you can do it just in a quick, short timeline. So, thallium-208 has a half-life of 3.053 minutes. We don't know the time lapse, but we do know that it decays from 120 grams to 7.5. Okay, there's my final mass. So how long did that take total if each half-life, the 4 half-lives, each one was 3.053 minutes? So if you are given the half-life, you will multiply by the number of half-lives. Okay, so 3.053 times 4 decays equals 12.2 minutes. Okay. The last one that I want to do is number 9. Potassium-42 has a half-life of 12.4 hours. How much of an 848 gram sample of potassium-42 will be left after 62, oh goodness, my lights went out. Excuse me, after 62 hours. Okay, so we're not given the ending amount. Okay, so we're going to have to be given enough information to figure that out. Half-life, time lapse, and amount. Okay, so it has a half-life of 12.4 hours. We know we started with 848 grams, and the time lapse is 62 hours. Okay, we need to figure out how many times this decays over 62 hours. So hopefully you're kind of getting the hang of things and you realize we're just dividing 62 by 12.4, and that's going to tell us how many arrows we have, how many half-lives we have, and that is 5 half-lives. So I'm going to draw 5 arrows. 1, 2, 3, 4, 5. And then I'm just going to split it in half every time. .5 grams is how much you would have left after 62 hours if your half-life were 12.4. So you don't have to do it this way every single time. Again, you can do it the way that I'm going to show you right now for number 2. Okay, so number 2 is probably going to be the same pattern as number 1. These are usually kind of grouped together. It says all isotopes of technetium are radioactive, but they have widely varying half-lives. If an 800 gram sample of technetium-99 decays to 100 grams of technetium-99 in 639,000 years, what is the half-life? So I'm going to start with my initial amount, and it tells me I can decay all the way to 100. So I'm just going to start there, cutting it in half until I get to 100. Okay, that took me 1, 2, 3 half-lives to get there, and my time lapse was 639,000 years. divided by 3 half-lives. That gives me 213,000 years as my half-life. Okay, so this is what your work can look like on your quiz tomorrow or your test on Friday. Okay, you are more than welcome to do it this way every time. Okay, your choice. Your third option is if you want to do it using the formula that I'm choosing not to teach you, and I don't think any of the chemistry teachers are teaching it that way. So it's not like you can go to tutorials for it somewhere else. You can come see me if you need it, but if you need help with that, then I'm going to make you do it this way. Alright guys, hopefully that helps you. Let me know if you need anything either in class if you're here or via Remind if you're at home. And I'll talk to you soon. Bye.